Just as there are multiple ways that the microscopic energy arrangement can change, there's multiple ways we can add energy to the system. We've already talked about adding thermal energy by a difference in temperature, which we call heating or a heat transfer. But we can also add thermal energy by work. For example, back in chapter 9, we talked about how friction across a surface added work and caused the surface and the block to get warmer. Well then, where else could we see this? Well, it turns out we can see it in a container filled with gas. So this container has a lid which is fairly tight. The gas can't get through it, but it is loose enough to slide up and down. This is called a piston, and the container is called a cylinder. Okay. Piston, cylinder. We use the same terminology when we start using these to describe engines, such as a steam engine or the reciprocating internal combustion engine in your car. Well, this piston has a certain area, A, and there's a pressure acting on it. So we can get a force equal to pressure times area. And then the work is equal to force times distance, where that would be the distance up or down that the piston moves. But if we put in our formula for force being pressure times area and regroup, well, the area times the distance moved is just the change in volume. So it turns out we have a new formula for work, namely, work is equal to pressure times the change in volume. And when we're dealing with work in a system of gas, we like to say it's positive if the volume increases and the system of gas does work on the outside. So if this volume increases, it's lifting the lead shot up. So the gas is doing work on its environment. If the volume decreases, the environment is doing work on the gas, and we call that negative. So now let's shrink this down. And bring in some examples.